Chapter 7, Number 40, another classic in the field. A new record for running the stairs in the Empire State Building was set on February 4th, 2003. The 86 flights, with a total of 1,576 steps, was run in 9 minutes and 33 seconds. If the height gain of each step was 0.20 meters and the mass of the runner was 70 grams, then what was his average power output during the climb in both watts and then in horsepower? All right, so the person has basically gone from the ground up some height, and he has moved against gravity, so he's had to exert a force upward on himself equal to his weight. So the total work done is going to be the mass of the person times g times that height. And then the height is going to be the number of steps times the height of each little individual part. So we pretend there are each of these little things. And we know that we have that this will be n, this will be little h, and eventually we'll get a time. Of course, we also have that this is the mass, and we know g. So the work done is going to be 70 kilograms times 9.81 meters per second squared times 1,576 steps times 0.20 meters per step, or a total work of 216,447.84 joules. And I'm going to keep that ridiculously precise number because it's not our final calculation. What we want is the power, and the power is the work divided by the time it takes. So it's going to be, so let's find the time, which isn't so bad. Let's go over here and say, well, the time was 9 minutes and 33 seconds, but 9 minutes is 540 seconds. So the total time is 577 seconds. And so our power turns out to be 21,6447.8 joules divided by 577 seconds, which is 375.126 watts. And now I should round to the right number of sig figs, which apparently are, oh, that's an interesting question, because I guess 2. So the question really is this 9 minutes? Should we worry about that being only 1 sig fig? And the guess here is, since we're even 9 minutes and 33 seconds, we can treat the 9 minutes as essentially exact. And it's the 33 seconds that controls, or the 0.2 meters. Anyway, we get 2 digits, so 380 watts. And then we can convert 380 watts times 1 horsepower per 746 watts, which gives us just about a half. In fact, it rounds to a half horsepowers, which is really not that impressive. Or maybe it is. Maybe the fact the person can pull themselves at half a horse is not bad.